Oh, great. Yeah, thank you. So once again, I want to appreciate every one of us for making it a date, from being part of this section. So this section is actually an advanced topic, whereby if you are new to database, database, you might not be able to get a lot, or at least we are going to break it down to the extent that everybody we understand. And so this little section, we want to talk about design, develop, and implementation of data warehouse in an enterprise environment. You know, it spans through a lot of roles. As a data engineer, you know, you can do this. As a data engineer, this is one of your part of it is part of your responsibility. As an ETL developer, it's also you also have a responsibility there. As a database administrator, you also have a responsibility, and as a data analyst, you have what you need to do here. So this topic will span through all that. So please, we want us to make use of the raising of hands. If you need to talk, you need to ask questions, you can just put up your hand so that everything will be coordinated. It will be coordinated. So we are going to kickstart now. As I said earlier, the topic is design, develop, implementation of data warehouse. So I'm not sure we're going to finish this course in a day, because I want us to understand it. So we might have to split it to two. However, we are going to see how where we are going to get to once we start now. So what we want to look at, first thing we want to look at is use case of a data warehouse. So people ask, why do we use data warehouse? What is the function of a data warehouse? Must we have a data warehouse? So we need to check the use case. Then the next thing is the designing and development of the data warehouse. Then after then, we talk about the ETL tools. We have a lot of ETL tools that you can use. Why do we use ETL? We are going to talk about that. So in this course, there are two tools we are going to consider: Pentahost tools, SSIS. The database we want to consider is PostgreSQL and SQL Server. I know that some of us might not be that familiar with PostgreSQL, but with this course, it will be an advantage to you to see the difference between the SQL Server and PostgreSQL, and see how you can develop yourself in using PostgreSQL. They are actually the same, but a little different. So we start. So the first thing, what is a data warehouse? You know, that's a question that anybody can ask. A database used and optimized for analytical purpose. So a data warehouse is a database that is used and optimized for analytical purpose. As we are all aware that we have two types of database. We have OLAP environment and OLTP environment. The OLTP is the transactional environment. That is where your daily activity, all the data, that's where they are going to. But OLAP, which is analytical environment, that is where you do your reporting. You would have observed that you have some companies that they will complain. One of their complaints is that, oh, they are trying to generate reports, but the thing is slow at a particular point in time, maybe in the morning or a particular time in a day, that everybody is on the server. When they are trying to generate some reports, when they are trying to do some traffic, the server is slow. What could cause that? That is because there was no data warehouse. That is because there was no load balancing. So one of the things that we also use data warehouse for is for a load balancing, whereby all your reporting activity will be taken from data warehouse, which is a separate database, while the transactional activity, day-to-day activity, will be taken from your database. So data warehouse is user-friendly. That is why we call it data warehouse. Fast query performance, enabling data analysis. In a data warehouse, we are aware, we all know that in a company, most company or all company, they use more than one application, and each application have their own separate database. And as the manager of the company, you know, you want to know what is going on across all the application, or you could have a CRM application called a customer relationship management application. You could have your ERP application, several applications. But with this help of data warehouse, you will be able to combine all this the data from all these applications together into one place. And from there, you can generate your report. So please, if you have any question, please, you can use the raise hands so that we can give you, because I want it to be an interactive class whereby everybody understand the concept of data warehouse. Okay, so the next slide. Yes, yes, we have a lot of data. Why need for a data warehouse? Why the company needs data warehouse? You know, one of the company, when I was interviewed for a company, you know, they asked me, okay, give us, told them a lot about myself, okay, database administrator. One of the questions they asked is that we don't just want you to be monitoring our server. We want you to be able to for us to be able to make use of our data. You know, companies have a lot of data that they are not usable. How are they not usable? Because they are complex data. They are just everywhere. So, but with the help of a data warehouse, all these are resolved. So yes, we have a lot of data, but we don't use it. Our data is very complicated and difficult to analyze. It's spread all over the different system and difficult to access. I just want to see what is relevant. We need to access data quick and easily. So these are the questions. These are the questions that data warehouse will answer. We have a lot of data, and as we know now, the new oil globally is data. The new oil money is data. Everybody is looking for a way to be able to get some information from data. That's the reason why we have big data analysis. Everything comes in from data warehouse. So I want you to prepare your mind on what you want to learn, the advantage of it. Okay, understanding the data warehouse. As I said from the beginning, that it is factual that companies have data from different applications. They have some application that they are client-facing application. We have some application that they are internal application, and each of the application, they have different databases. But you cannot tell your CEO, you cannot tell the company chairman that, oh, this report is from this particular application, this other report is from this particular application, this other report is from a particular application. So you need to have all these together in one repository, which is data warehouse. From the diagram we have here, you can see other data source, we have sales data, we have CRM data. So all these data from these databases, they are combined together. They are extracted, transformed, and loaded inside the data warehouse. Now, we are not just talking about on-prem, because the future of data is cloud. Now, in cloud, once the data is extracted, they are dumped inside the data lake. From data lake goes to data factory. But let's continue with this. So as I was saying, so we have all these different data, they were combined together, and they were deposited into a data warehouse. Okay, so understanding the data warehouse, what do we do? So this is a demonstration. What we do is that since we have three different data, we can have as many, more than three, as many as you want to have, you can have that, different databases, but you only have one data warehouse, depend on the use case of data warehouse. So now what we do is data is extracted from each of the databases, transform and load. Now we are going to see the reason why it is transformed, and I think it's obvious because the data type from database A might be different from data type in database B. And for them, before you can move it to a data warehouse, which you have to have a uniform data, you must have transformed it. So that's the essence of the transformation and load. This, as I said from the beginning, that we are going to have a practical class where we are going to see it real life, how data is moving, when data is updated, and the effect on the data warehouse. So I want us to understand the theoretical part very well before we go into that. So the next one are goals of a data warehouse. Why are we doing this? We want to have a centralized and consistent location for data. Data must be accessible fast, query performance, user-friendly, must load data consistently and repeatedly, reporting and data visualization built on top. These are the reason why we need to have a data warehouse, so that all our data from all these databases, they are centralized. You are able to find them in a particular repository, so that whenever you place your reporting system on top of it, the reporting system will not give you reports based on the database. It's giving you the report based on what is in the data warehouse. And you also know, for a transactional database, at the beginning I explained, apology to newbies into data, but I believe once you follow us, you are going to understand it better. And after this course, I think we can, because I know we have a lot of people joining external, so we will want you to drop your number. We will create a separate WhatsApp group for follow-up, because after this training, we are planning on going on into an analytical training, analytical webinar, so that we can communicate to you how it's going to go. So please, on the comment section, you can drop your number. We are going to capture it and have it as a register for this training. So we continue. So this is the reason why we need to have a data warehouse. So which means if you are in an environment and they don't have a data warehouse, something is missing. One of the reasons is because of load balancing. The way a transactional database is designed is not designed for fast data retrieval. For you to have fast data retrieval, you must put your indexes where it's supposed to be. You cannot use the same index that you use for an OLAP environment. You cannot use the same index for an OLTP environment. So when a company or when someone is complaining that, oh, this particular whenever we want to generate report, it's taking time, it makes our server to run slow. When someone is generating, that's the reason why when they want to generate such a report, they do it off work hour. However, if a data warehouse is available, it is a separate database that is controlling the reporting system. So what are the reporting systems that are built on data warehouse? We have some visualization tools. One of them is a Power BI. We have Tableau. We have SSRS. We are going to look at it in this
that's what I'm asking,
section.
right? Like yourself is verifying the log.
Please, if you have questions, please, you can, as we proceed, you can put up your hand while we answer your question. So we'll proceed. Understanding the data warehouse. What do we do? Now we are going into it squarely. In a data warehouse, how do we design a data warehouse? The first thing you design, there are three things that are involved. You have your staging environment, and you have your core environment, which is your data warehouse. All of them, they are called data warehouse. Why do we have staging? Why do we have staging environment? The reason why we have staging environment is that we do not want to place our transformation analysis, our transformation service on the production server, so that it will not have impact on its resources. So we have a staging. What do we do in staging? Staging here is just like a data lake. What we are doing in staging is that we are capturing the data from all the databases, and we are capturing it the way they are without any transformation. However, you could put a little transformation. So you are capturing the way they are, putting it on a staging environment. Now it is on the staging environment that you now build your load and transformation tools to transformation and load, whereby it will transform the data and load it into data warehouse. We are going to practicalize this. It's not abstract. We are going to do that today. So we have staging environment and we have core environment, which is the data warehouse. You could, I don't know if you have observed in some environments, when you see their pipeline, data pipeline, we call it data pipeline. Your ETL plan. If you remember, this topic is saying design, develop, and implementation of data warehouse. So what is the design there is designing the pipeline, which shows the direction of the data, where data is moving from one point to another, and when the transformation is working upon it, that is the designing. We are going to see it in action. So we proceed. For instance, now we have two data sources, databases, different databases. It could be an Excel. It could be from your SQL database. It could be from your ProgreSQL database, from different sources. Two of them are coming. In this instance now, this is still okay. The two of them, this data, this department 1 is coming from this particular database. This department 2 is coming from this database. In this scenario now, we don't need more transformation, because if you look at it, they have the same data type and they have the same data structure. You can see the employee ID. So with this, you can just move the two of them directly to the data warehouse. Let's see how it moves. Look at it here. The two of them, we move them directly to the staging environment. You know, on staging environment, that is the first step whereby you combine all the data the way they are. You combine them and put them on staging environment. However, on staging environment, you can do little transformation, but not an acute transformation that you are going to do on the data warehouse itself. So look at this now. So we're able to do this easily because they have the same data structure. So let's see the next one. Look at this next one now. We have different, if you see it very well, I mean, if you check this very well, although we have the same employee ID, we have the same entry date, but do we have the same position? Look at in the first database, look at the column name, position underscore level. Look at the column name on department. Can we see different? Can you see the difference, please? Let's if you want to, you can answer, please.
Yes, go ahead. We can see the difference.
Oh, thank you. Now you can see the way they put the HR here. In the second database, we have human resources. So in this case, now you cannot move this directly to the data warehouse. You have to make them to be conform. You have to make them to conform to what is going to the data warehouse. So in this case, now you have to do a little transformation. And what is the transformation? Setting that whenever you see HR, put human resource. It depends on whichever one you want to stick with. So that is that. So the next one is this data warehouse layer. This is how it works. As I explained at the beginning that we have staging and we have core. The core is the data warehouse itself. Then what do we use data warehouse for? I said it is for analytical service, which is for reporting, basically for reporting. Look at the tools that we have here. So on this data warehouse, we have Power BI, we have Q-Link, we have Tableau, and we have predictive analysis. The predictive analysis is the big data. What do we use big data for? When you have you want to do predictive analysis, you want to use data model, you want to use machine learning, everything can be connected to the data warehouse. You get all that? So now, the next slide, I want to take us through what I quickly did with this practical we are going to do with this data warehouse on Power BI and also SSRS.
Is this section, sorry to cut you in, but Alaka, is this session being recorded?
Yes, yes. It's being recorded. I thought, please confirm.
Yeah, I think it's being recorded. I see recording.
All right. Yeah. All right. So the next one is that I want to show us some use cases of a data warehouse, which we are going to do in this course. But we are not going to go into the Power BI training or the SSRS training now. It's another course. But I just want to show us how they work together. So now this is the database that was used to create the data warehouse. I use ProgreSQL. We are going to use ProgreSQL, and after then we are going to use SQL Server. And as I said, ProgreSQL and SQL Server, they are similar. You only have little different. To me, I would say there is no difference if you check it very well. So this is the data warehouse that I created today. It's a sample, which is what we are going to use today. So this data, after creating this data warehouse, I created a Power BI reporting system, which is getting its information from this data warehouse. So I want to take us there to show us how it works. Okay, let's take this. Okay, so this is the Power. No, this is not the Power BI. Okay, let me just come here. Okay, so we're going to see how it works now. I'm opening the Power BI now. Okay. So once we're able to create these reports, this is okay. Good. This is what we'll be able to get. So you will see how everything works together because we are working on data warehouse. So I just did this today. This is data warehouse that we are going to use for practice. So look at this. The first thing is this. Now on data warehouse, we have 4 tables. These tables, they are the tables from, these tables are gotten from the data warehouse. And before we're able to get this, before we're able to get this, we did extraction, we did transformation, and we did load. So if there is any changes on the production environment, there will be changes here. Now look at this. After we're able to do the data warehouse, this is what we got. We are going to get this. We are going to explain this. It's a star schema. All these are connected together. So what the advantage of this now is that, look at this now. With this, if you click on any of this, if I click on any of this, this is date now. This is a report that is showing the cost and price by category, by product. If I click on this product name, it's going to change everything here. Can you see that? This is the function of the data warehouse. Everything are connected together. All the data are connected together. If I want to say, okay, I want to know, come back here. I want to cost by payment. These are different payment type. MasterCard, American payment, American Express, Visa card, cash. If I want to know that, I want to know the number of items that were bought with cash. I just come here, I click on cash. It's going to show me here. It's going to change everything. I see quantity is the quantity, there's the cost, there's the price, there's the profit. And this is the cost and price by category. I want to check. These are the use case of the data warehouse. With data warehouse, you'll be able to get all this. I can drill down to, this is per year now. I can drill down, I know. I want to see per month. I can click here. It's going to change everything. That this particular, in October 2021, how many items was sold? I can see the quantity is this. The cost of the item, the profit that was made in October. In January 2022, what is the profit? You can see everything is changing. That is the work of a data warehouse. All this table were gotten from a data warehouse. So that is that. So let me go back to the slide and show us the next. We are here. Okay. Can you see my screen? Please confirm. Yeah, I can see my screen.
Yes, we can see your screen.
All right. Thank you. So the next one is SSRS demo. So these are the use case of the data warehouse. When you have your data warehouse created, all these things can be done seamlessly. Now, at the beginning of this course, I said this particular course has 4 roles together. As a data engineer, you have a work to do here. As an ETL developer, is a role on its own to develop the movement of the data from the production environment to the staging environment to the data warehouse, to design the pipeline. That is the work of a ETL developer. As a database administrator too, you also have your what you need to do here. You need to all the roles. You need to understand how everything works together. And as a data analyst, you need to understand it. If your database administrator is not giving you the right thing, you will be able to ask questions. I know this is how the data warehouse should be designed. I should have all these things connected already. This is what I want, and this is so. This is a demo of an SSRS that is created on a data warehouse. This is another demo of a SSRS, another thing table. You can see from this. This is just a normal table that you have on your SQL Server, normal table, and you are able to filter through all this. If you have any of these parameters, you can say, no, I do not have this parameter. This is what I want. You are able to filter. You are able to do everything and click on view report. And in little time, you get your report. And all these, please, it is advisable and it is a best practice that you don't build your report service on your production server. And why? We all know the reason. Because you don't want your, please, you people, please drop your phone number drop your phone number so that we can have you. Okay, I can see some have dropped theirs. I will need to record after, please. Okay, good. Okay, so we'll proceed. So these are the use cases of a data warehouse. So we are going into it. Now, we talk about ETL tools now. ETL tools. As I said from the beginning that we have a lot of ETL tools. What is ETL tools? That is what you use to design the data movement from the production environment to the staging environment and to the data warehouse. So look at the ETL tools we have here. We have a lot, but we are going to consider two. If you look at it critically, some of them are specific for a particular type of database. So we have all these, we have Informatic, we have Oracle Data Integrator, we have Microsoft SSIS, we have Talend, Open Studio, we have Pentaho, Data Integration, AdHoop, Azure Data Factory, AWS, we have all these. But we are going to consider two. We are going to consider the SSIS and we are going to consider the Pentaho Data Integration. Okay, staging environment. We all understand what staging environment is. Staging layer is the landing zone for extracted data. Data in tables and on separate. So staging layer, the work of the staging layer is for it to collect data from all the connecting database. You remember, one of the connecting database could be an Excel file. It could be a CSV file. You know, there are some companies that they still keep their data on CSV. It could be maybe attendance or some register, and you want to bring everything to data warehouse because you want to create the reports. You know, so in a staging environment, you have a little touch. You know, you don't want to build your transformation service on your production environment so that it will not impact on the database resource. We don't change the source system. Then the staging area could be temporary or persistent. What do we mean by this? You know, in one of the design, you could decide that, okay, I don't want to, whatever data I have is correct. I don't want to have, once I'm collecting data, once you get to the staging layer, once staging layer has sent it to the data warehouse, the data in the staging layer should be deleted. But the next time it's getting a new data like that. So it could be temporal and it could be persistent. So what is dimensioning modeling? Dimensioning. So we are going into the designing now. In a data warehouse, you have two things. You have a dimension table and a fact table. So what is dimensional modeling? This is where you have your database designing now. You want to design it now before you develop it. Designing means you want to be able to separate the information to fact and dimension. From the word fact, fact means measurement. Fact means what you can use to measure other things. Then dimensional, from the word dimensional, it means like category. Category, I want your contribution here. We'll go to the next slide. So now we have dimensional modeling, method of organizing data in the data warehouse. There are two methods, in fact and in dimension. In fact, what are we talking about in fact? Profit, what measurement? What are the things that you can use to measure? And in dimension, context like category or period. What are the things that you can use that measurement to get? For instance, let me give as an example. Like, okay, in a supermarket, they want to know the location, the state. Let me put it like that. In a supermarket, okay, don't let me say supermarket. Let's say Jumia. Let's say Jumia. No, most of us you're familiar with Jumia. Jumia might want to say, okay, I want to know the state, the location that is having higher purchase on our platform. Let's know the location that we are having a lot of profit. So with that, let's see what we can do for them. Maybe that location we can or maybe we need to focus on other location on our advertisement. That's the report. They want to know the location that they're having their higher purchase, the location that they have a lot of inflows. So in that case, can someone tell me what would be the fact and what would be the dimension? I want your contribution.
Sorry, I'm not following. There's a noise coming from somewhere. If you can you rephrase the question?
Okay. Thank you. So please, we are dropping your number, drop it with the country code so that we can get it right. Okay, yeah, the question is that, so for instance, Jumia, I know some of us are familiar with Jumia. Jumia want to get an analysis report. They want to know the location that is patronizing them more than others. They want to know the location that is having more inflow in their platform. And why? They need this report. They can need this report for different things. Number one, they want to know the location to focus more on the advertisement. If they see that, oh, this location we're having lower inflow, what do we do? Do we do more advertisement? Do we have physical location there? Do you understand? So they want. So I'm not asking, in this type of scenario, what will be the fact and what will be the dimension for this kind of report, for this kind of analysis? I'm waiting for your contribution.
Well, I don't know. I think the fact will be the actual results, the actual result. Like someone posted a no sales, number of sales. So the more adverts you do, the higher number of sales. So the number of sales can be the fact.
Okay.
I don't know what the dimension would be.
Okay, thank you very much. Do we have someone else that want to contribute?
Please. I think
I'm waiting for others to contribute.
Because when I it's like I have to change the settings, right? Yeah.
More contribution, please. So is it safe to say that the dimension is now the target audience, like the people that sales is directed towards? I don't know. Okay, yeah, you're trying. Want more? Okay, let me just give us the answer. So we all try. Thank you very much, because this training is for us to understand it, not just to come and run slide, for us to understand it. Now, thank you very much, Mr. John. The fact, I said fact is what you can measure. Fact is actually the quantity. Now, it depends on what they want. Now, they want to know the number of sales that is coming from those directions. If it is the number of sales, that is count, quantity. If it is the amount, that is the cost or price, that is fact. Those are fact. Then dimension, number one, dimension, one of the dimension is location. The main dimension is location. Location, that's the dimension. We want to know the number of people buying this, the number of the quantity that is purchased per location. Can you get that? Quantity by location. And you could also be by customer. But if you want to do it by customer, in that case, we can actually do it by customer, but that is in another, oh my God.
I can't see anything again. Are you guys still hearing Alaka?
No, it's frozen. No, it's frozen.
Power is out.
It looks like he had a low battery. Like that.
Or maybe network. Let me try to see that.
No, it's low battery. Okay, it's back.
Yeah, sorry, I had a little outage. I'm back now. I'm back.
Okay.
That's Niger Factor.
Thank you.
Niger Factor must enter.
Sorry for that. So as I was saying, so now we now understand what is measurement and what is dimension. Dimension could be by customer. So which means you want to know, because like someone like me now, I might be a good customer of them. Okay, one of it is that they want to compensate maybe someone that they want to compensate highest they want to compensate people that have the highest inflow, highest purchase on their platform. When I have an account on Jumia, I know some of we also have an account on Jumia. So with that, they can also use that as a dimension. With that dimension can give them the count of the time, the number of time that I have gone there to purchase something. So you can see how it works now, how they relate. Fact is what you can measure, while dimension is what you use to do the measurement. So for this, in this instance now, like profit, date is also a dimension. You could say, okay, they want to know the number of sales in they want to know the year that they have the highest number of sales. So with that, they can say, let's look at 5 years from 2015 or 2017 to 2022. In that case, dimension is date, and the fact is the quantity, the number of sales. So I hope we understand. Okay, we proceed. So the next one here is that so now we're going into the practical dimensional modeling. So now we have, as we if you remember when we are using Jumia as an example, where we talk about many dimensions. Number 1, location. Number 2, the customer itself. Number 3, date. We still have more other dimension. Who can give us any other dimension that you think that they can use as to qualify their measurements? Which other dimension can they have? Can Jumia have? Which other dimension?
They can use the products, the type of products being sold.
Wow. Awesome. Great. You're right. Product. Also, you also know other location. They can also use country. Under location, you can say, okay, which country? Yeah. It's not only in Nigeria that use
What about amount?
Amount. So amount will be in fact, because it's measurable. It's what they use to. Now you can say, I want to know the amount per location. They want to know per state. They want to know the states that have purchased highest number of things from them. That is amount per location. But what is the fact? Amount. So we need to understand what is fact and what is dimension, because that is the basic, the background of your designing, of your data warehouse designing. Good. So we have a lot of dimension. You can see in this case now, we have 3 dimensions. This is the star schema. Why do we call it star schema? Its name implies what we are seeing. You can see it is in form of star. We call it a star schema because the fact table is connected to each of the dimension. We have another case that dimension is connected to dimension. Why are we doing all this? Why are we dividing tables to fact and dimension? We call it normalization. We are trying to normalize it. One, for fast data retrieval, to reduce redundancy. What do we mean by redundancy? Now, if I have a big table, I have the cost, I have the number of quantity, I have the amount, and I have the country, I have the location. Now, let's say the location is state now. I have the state location. Now, if in that case now, you will agree with me that on a particular table, because a lot of people in one product, 100 people from a particular location can purchase that product. Another product, 50 people in another location can purchase. With that, we're having a large table. We're having redundant. You are having what you are, database, your storage is getting filled up. But if the table is normalized, is divided into different in fact and dimension, we are going to see how they connect together. In that case, once you divide the table, you connect them together. When you connect, we have primary key and you have foreign key. We are going to get there. We are going to understand it. But now I want you to understand why we divide into fact and dimension. Now, dimensioning modeling. Why do we do dimensioning modeling? Unique techniques of structuring data. unique techniques for location. Now I can see for my location, for you to be able to drill down to in a particular report, it means you must have enough information. The instance I gave, that in a particular table you have the location. In a location now, location we have country, location we have state, location we have local government, location we have house number. If you have all those information on one table, you can't imagine how large the table will be. So this is one of the advantage of having a dimension model, whereby every information particular to that scenario will be in the same table. For location, the location now, we can have a location table, whereby in the location table, you have the country, you have the state, you have the local government, you have the street, you have the house number. You can have a customer table. In the customer table, you have the customer name, you have the customer phone number, you have the customer email, you have the customer address, you have the customer next of kin. But if you are to have all that on a single table with the measurement, the table will be so big. And even when you are in that case, when you're trying to generate a report, it will be so slow. So now I think you are seeing the advantage of the data warehouse. So if you are a data analyst in the house, these are the advantage of the data warehouse. When you design your Power BI report, or you design your Tableau report, you design your SSRS, and you observe that, oh, when you click on something, it's just getting slow. Why do we have that? Because there is no data warehouse. So the dimensional modeling is commonly used in data. Okay, you have a question?
Yeah, this dimensional modeling, is it the same thing as partitioning?
Okay, thank you for that question. It's not the same thing. It's not the same thing as partitioning.
Okay.
Okay, yeah, thank you. So optimize for faster data retrieval. That is why you're having dimension for faster data retrieval. You remember, as I said, we have big data. What we use in big data, why do we call it? Someone asked me a question today that why do they used to segregate a data analyst and a big data analyst? The person asked me that, what is the difference? I said the difference is that big data is getting his own data from something big, from a voluminous data. But a data analyst might not be getting his data from a voluminous. What do I mean by a voluminous data? You know, you have a big data that, you know, I was also explaining to someone that all these this picture scanning, I mean, your video authentication, everything is data. Everything is data. That's the reason why what the new oil now globally is data, because they put one or two data together to be able to. What we do in as a data science, most of the thing we do is that we do predictive analysis. What is predictive analysis? You look at an history data for a large period of time, and you look at it that, okay, from this time to this time, if this can happen, then there is probability that it's going to happen again. Some of you that do, some of us that do, no, they don't do. There are some people that do this football betting. You know, one of the things that they do, they work with history. They look at, oh, this match, they played this match this time ago. For this to be, for this club to win, it means this, you know, we have predictive analysis. That is what they do in data science. Data science work with big data. You have a lot of data to be able to test your model. You create a model, you train the model, you test the model, then you now push it to live. So from there, all you need to do is just to put parameters. Just put parameters. They do it in such a way that the only thing you know, maybe you put only dates and some other things, and it's going to give you a predictive analysis. Predictive analysis in probability. And once you have a probability above 0.5, close to 9, when you have a probability of 9, it means it's going to happen. That is what we do as a data scientist. So, and everything starts from data warehouse. As a data scientist, you are getting your report, you are getting your data input from data warehouse. From data warehouse. So that's it. So optimize for faster data retrieval, oriented around performance and usability, designed reporting, OLAPs. So that is what the dimensional model is designed for. Okay, so we have this dimensional modeling. So we have this now. This is an example. We have this table. Let's look at this table. On this single table, we have a lot of information. We have date, we have product, we have category, this product category, we have customer ID, we have profit. On this table, this is a fact table. I mean, this can be channeled to be a fact table. Why do I call it a fact table? Because of this profit I see there. Profit. This profit is a measurement. I can use it to measure other things. It's a fact table. Let's see what we're able to get. From this table now, if I want to get a lot of information from here, it means I'm going to have a date dimension. Here, the only data I'm seeing is just one. What if I want to see the report per quarter? What if I want to see the report per year? What if I want to see the report per month? I will not be able to achieve that if my report is based only on what I have here. But if the report, if this thing is extended, having a dimension table whereby all other information are kept, I'll be able to achieve that. So next slide. So look at this next slide now. Dimensional model. So oriented around performance and usability. So yeah, we have the profit. This is a fact table. I told you the other that it's a fact table. And why is it a fact table? Because we have a measurement value there. Profit, quantity, cost. You use it to do measurements. Then we have this is a product dimension. In a product dimension, you are expected to have everything about the product, all the information about the product. All the information about the product, you are expected to have it here. Now look at this. The principle, the concept of foreign key and primary key. Primary key from the word primary, parents, the owner. On every table, we are aware that you should have, if it is not an heap table, you should have a key column, a primary key on every table. Why do we have it? Why do we have a primary key? A primary key is automatically an index column, whereby if you filter with that column, you will have a faster data retrieval. So now, if I'm having a dimension table, a product dimension table, it means each line are unique. It means the first row have information of a particular product, and every other thing in that row, every other column in that row, they are relating to that product. So this is what we have. This. So with this now, so we have this now. So now on foreign key, every other tables that your fact table is connecting to, your fact table must have its foreign key. From the word foreign, foreign means outside. Like we have some of us here that they are foreigners. They are Nigerian, or we are bringing you back. So let's proceed. So foreign key, you can see here we have product ID. Product ID here. This product ID is a foreign key. Foreign key might not be, I mean, cannot be, you don't need to have it as a unique key. It's not unique. For instance, look at this now. Do you have any repeated one? Okay. Foreign key is not unique. You know, you have it on the fact table. So anything that is happening on the fact table, the system will automatically relate it. Once the foreign key is the same thing with the primary key, it's going to you'll be able to filter for other information. For instance, let me bring back my Power BI for us to understand it very well. Look at this Power BI now. What is going on here is a function for these people to be able to interact with one another. What you are seeing here, they are different tables. What you are seeing here, for them to be able to, as I click on one, is changing orders. For them to be able to interact with one another, it means there is a connection between them. There is a connection, a primary key and a foreign key. Look at the diagram here. This is the diagram. This is the fact table. This is the date dimension. This is the product dimension, and this is the payment dimension. You can have as many as you want. Look at this, they are related together. Now, if you check this thing very well, for this product dimension now, this thing is connecting, this is primary key, product ID. And on this fact table, you must have foreign key, product ID. If I click on this, you can see their relationship. They are connected together. So this is the objective, our aim of creating a data warehouse, for all the tables to be connected together, so that anybody that is working as a data analyst on it will not have any problem. Look at this now. When I was creating this model, I use these two things together from different table. Use this information. This is a particular table. Look at the table now. This is where you see those tables. This is date table. You can see them. This is payment table. This is product table. They are separate table. This is sales table, separate table.
Mr. Laka,
okay, please ask a question.
My understanding with what you're doing now, you are creating a data warehouse from scratch, right?
Yes.
Okay, which I understand. But yeah, my question comes in when you're talking about constraint, which is the primary key and the foreign keys. Now,
okay,
let us look at a scenario whereby you're trying to do ETL, whereby my understanding about ETL is that when you have a data from different sources and you want to integrate all those data into your data warehouse, and when you are collecting data from different sources, there is a need for you to actually extract those data from different sources, and you have to transform the data. During the transformation process, my understanding is that you have to get rid of some of the constraints that is coming from different data sources before you eventually load it to the data warehouse. Okay. Is that right?
Okay, well, it's part of the transformation process. If you join from the beginning, we have a staging environment as the first thing. When you are bringing in your data, the way it is, you can only do little transformation. You bring everything into staging environments, and from staging, transformation begins.
Okay, so you have to transform it to the structure you have in your data warehouse in terms of the tables you have and some other stuff like that.
Yes, yeah, you're right. You transform it to that structure. We are going to see it in practice.
Okay,
thank you very much. All right. So now, can we see this now? These are different tables. And when I get to my analytics platform, I was able to connect different columns from different tables, disparate tables, and I was able to use it to form a reasonable report. Can we see all these? They are from, you can see this is from payment table, this is from sales table. Why was I able to do this? Because all the data are already connected in the data warehouse. That is the function of data warehouse, to connect those data together. Someone was asking a question here. Data warehouse is more or less used for storage, analogous estimation. It's not very accurate. Well, I think I disagree this. Data warehouse is not used for storage. It's not. It could be used for storage, but it's not. That's not the purpose of a data warehouse. If we are talking about storage, we have data. We have replication. You have log shipping. You have mirroring. You can use all that for your BCP to store your data in case of disaster. But data warehouse, the function of a data warehouse is model for reporting, for analytical purpose. That's the reason why we are doing all these constraints, all this connection. If it is for storage, I don't need to do connection. All I need to do is just to put everything into staging. I don't need to do any transformation if it is used for storage. So I quite disagree with that. So let's continue. So now I think we are getting it, because I want us to understand it. It's not just a class, but I want us to understand it. So we are here. Okay, so we are here now. Let's proceed. So yeah, so now we understand foreign key and primary key. So in this case now, we have fact table and we have product dimension table. So the next one here, we have fact table again, and we have date table. Can we see that now? So all this single fact table is connected to all this dimension table for you to be able to have reasonable reports. It is what you put into the system that the system will give to you. It is the dimension you put there that you will be able to get the reports. If I do not put date table, I will not be able to filter my report per month, per day, or whatsoever. I show you the SSRS report, how everything works together. On the SSRS report that I show us, we were able to see that you can filter with different parameters. You can filter with date. You can filter with the project name. It depends on your report. And everything, it depends on the way you structure your data warehouse. So the next thing now is we have this, we have fact. We can see how they connected now. Now, fact, foundation of data warehouse, key measurement, aggregated and analyzed. That is fact. Fact is the foundation of data warehouse. If there is no fact, what are you measuring? However, we have factless table. I'm going to see that. But fact is mainly the foundation of data warehouse and this key measurement. Remember that in your fact table, you must have all the foreign key of all the dimension table that is connecting to that fact table. Here, the fact table here is the sales. You can see sales now. Sales we have sales ID. This is his own primary key. We have product ID connecting to this product ID here. Go back. We have customer ID connecting to this customer ID here. And we have date ID connecting to this date ID here. Everything you have here is the foreign key, but on each of the dimension table, you have a primary key. Now, look at what we have here. We have unit and we have price. This is the main fact. Fact in a fact table. Fact is the measurement in a fact table. So when we say we have factless table, it means there is no measurement in that table. So usually non-aggregatable measurement versus descriptive mode. So this is dimension. Oh, I've come to dimension. We are on fact. So this is fact now. So fact is aggregatable, which means I can say now, on your fact table, it depends on the grain. What do I mean by the grain? It depends on the level you want to drill down your report. For instance, the example that we use, that Jumia could say, I want to see the total amount purchased in a year. In 2020, they have the list of all their users. I mean, all the they have the use of all their customer, which are one of their customer. You are also one of their customer. They have a list. They can say, I want to know the amount of goods that Alaka purchased from them in year 2010, 2020, 2021, 2022. They want to see it for all their customer. That is one grain. In that case, now they're able to aggregate. They sum all the, it's not one thing I purchased from them. I purchased many things, but they sum the summable, aggregatable. They're able to sum everything together and use dimension to give out the report. And they could say, no, they want to check it per month. So when you are designing your fact table, you use the lowest grain. Remember, it is what you put into the system that you're going to get. You put the lowest grain, whereby on your report, you can filter. On your report, you can filter. I will still go back to this. It's more explainable. Now, what this particular pie chart has two information. It has false or true. Loyalty card. This is it. Loyalty card is saying payment. This is payment process. There are two payment process. Some of them they use loyalty card. Some of them they did not use it. If you use it, say true. If you do not use it, it's false. Now, this thing is iterating over all the requests on all the products, iterating over them. But when you click on this report now is giving us the sum. I can show you, I can do it such a way that we are going to see the amount, not just the percentage. So we are not doing this thing, but I'm going to show you. This is it. Data value. You can see the value. So the value, which is the summation of everything for false, for true. This is true. True. People that use loyalty card is 1.34K. K is 1,000. Depending on your unit. Can you see it here? Profit by profit. Can you see the amount here? Can you see? And if you want to drill this thing down, you can drill it down. So for us to be able to achieve this, it means when we are creating the fact table, we use the lowest grain. Well, assuming when I was creating a fact table, I already sum everything, you will not be able to drill down. So those are the things that you consider when you are designing the fact table. So this is dimension table. So just opposite to fact table, dimension table is non-aggregatable. You cannot aggregate country. You cannot aggregate location. You cannot aggregate customer. It's just something measurable. So from this, you remember when we talk about ETL designing, it's designing. You sit down, you look at the available table. The first thing is that look at the business requirements. What is the business requirements? What did we want to achieve? What are the type of report I want to achieve with this? Then what should be my fact? What should be my dimension? That's all. So categorize fact, supportive and descriptive, filtering, grouping, and labeling. Use it to filter. Use it to filter. From my report here, sorry, I'm going back to the report. From my report now, I can bring up, let me take this off. I can bring up a slicer. And this slicer, I want it to be date. From this slicer, I can come here that, okay, I call it date. This slicer, I call it date. I can filter with this date. That I want to know the cost from this time to this time is going to change. Look at this. It means from 2020 to 2015. I can come here and select dates. And it's going to, I can select a particular day. That what is the profit on a particular day is going to give me. Are we following? Are we following? Yes. So you see how they are controlling one another. So a date table that is separate, I'm able to use it to control all other tables. Why? Because they are connected in the data warehouse. So data warehouse is model designed for reporting and nothing more. Designed for reporting. So let's proceed. Okay, so we are here, dimension, we understand this. This is star schema. Now, I was explaining star schema the other time. Star schema is that all the dimension, they are connected directly to the fact table. Fact table. Nothing is connected to them. And why do we have this? Remember, I mentioned, look at this one. This is a product dimension. And this is a fact table. Now, instead of me to have all this information joined to this table, then we take it out to reduce redundancy, to avoid redundancy. So with this, it means from this, I can easily know, once I know the customer ID, I can know the product that this customer purchased. Who can tell me this customer ID 23? Who can tell me the product that this man purchased? How many products? Which products did he purchase? What's the name of the product that this customer ID 23 purchased?
Banana, fruits and vegetables and fruits. Is that one? Number 3?
You are the best. Thank you very much. You see how easy it is? Welcome. The connection. We are able to connect the foreign key with the primary key. So whenever I need an information from this 23, it can easily go to all connected dimension table to get me the information. Please, do we understand that? Do we have anyone that don't understand what Mr. John just answered? Do you have anyone in the class that don't understand that?
Can you explain once more?
Okay, thank you. Thank you very much. So what we're saying is star schema. This is star schema whereby each dimension is connected to a fact table. And when a dimension table is connected to a fact table, there is something that is linking them together, which is the primary key on the parent dimension table and the foreign key on the fact table. In this scenario, this is the fact table and this is the dimension table. And for us to be able to connect these two tables together, we were able to join this primary key of this dimension, of this product, this thing, to this foreign key on the fact table. And once you join it, it's looking at this ID whatever you have on this ID, if you come here, it's the same information. So the question I asked that for this customer 23, what is the product name? What product did he purchase? We can easily see that this customer 23 purchased product ID 3. And what is product ID 3 on product table? If we come down here, we are going to see it. Product ID 3 is banana. While the category is fruit and vegetable, subcategory is fruits. Do you get that? Do you understand?
Yes. Yes, thank you.
Thank you. Thank you for that. So another thing that I want to bring in here is that on generating your key, one of the modifications you are going to do, I know most of us must have heard about it, about surrogate key. We have surrogate key, and you have surrogate key is an alternative key. We have surrogate key and we have your main key. Every table, like in the company I work with, we have an employee table. And what is the key? What is the primary key of employee table? The primary key is the employee number. Employee number. Employee number could be DZ001, A200. Employee number, the more they create it, which is the number on your ID card. So in that case, if I want to work on such table, employee table will serve as a dimension table. If I want to work on it, it means I have to create an alternate key, which is the surrogate key. We are going to get there. Why do I do that? Why do I use surrogate key? Why didn't I use the key directly? Number one, the key, it is alphanumeric. One of the, when you are designing a table in a database, one of the things you consider is the usability and for you data retriever, for you to be able to retrieve data as fast as possible. It's research, and the standard is that when you use an integer as your primary key, as your index column, it is easier to filter for you to return your query fast. Number one. And the surrogate key you are using is auto-generated key. You are not the one that input it. Number two, why you use surrogate key is that on your primary key, someone can just come one day and say, oh, my employee ID, I don't like it again. Why will I be 002? And I came first in the company as 001. Please let me change it to 001. You can change such. And when you change it, it will destabilize your data warehouse because it is connected to other places. So in that case, when you use your surrogate key, which is automatically generated by the data warehouse itself, there won't be any reason why you have any deletion. So it will be a unique key. Then it will return your query faster. It's simple to generate. We are going to get there. We are going to do it. So now, this is look at this now. This is a star schema. The next slide, the next thing we are going to is snowflake schema. So I want to show you the difference between star schema and snowflake schema.
There's a question on the chat. There's a question on the chat.
Okay. That explanation seems technical. That explanation seems technical. Can we say customer 13, 16, and 23 purchase the same item because they share the same product ID? Oh, awesome. Can we say, okay, thank you. Thank you for that. Customer 23, 13. Okay, no, the reason why we're having a dimension table, the reason why dimension table is created is to reduce redundancy. In this case, assuming that we do not have a dimension table, that we want to put all this information from here, it is obvious. Customer 23 purchase 3 banana. We put banana here. We put we extend this table. We create another column. We put all this information there. This same customer 16 also purchase banana. We also put the same information. This customer 13 also purchased banana. We put the same information. And in how many places now? Number one, we have consumed space. I hope you agree with me. Number two, data redundancy. When you have too much of data, it will be difficult for you to have fast retrieval. Now, if you understand physical logic, physical load and logical load, when you check your execution plan, when you run a query and you check your execution plan, you have your logical load, and then your physical search or physical load. You search that. What the system is doing is that when you, like in this case now, if I want to filter I want to get information for only customer 23, I'm going to write select the fact table where customer ID is equal to 23. What the system is doing is that it's going to iterate through all the rows that you have in that table and come back and give you the result. If you have more rows, what will happen? It will increase the time that you are going to get your reports. So this is the reason why we have dimension. We call it normalization. This is the reason why we normalize our table, such that instead of having banana, fruit, vegetable, fruit in 3 different spaces here, I only have it in one place here. Can you now see the advantage? So I also mentioned that product ID, dimension ID on the fact table, it is a foreign key, and foreign key is not unique. You can have as many duplicates. The only thing that is unique is primary key. You can see on this product table, dimension table, you have primary key, and you can never have a duplicate. They are unique. You have 1, 2, 3, 4, 5. The same thing on this sales fact table. You have 1, 2, 3, 4, 5. But here, this particular one is a foreign key, and foreign key can be duplicates. And the fact is that's the reason why we have a dimension table. The same thing with customer ID, can be duplicates. You can see we have 13 here. It could be duplicate, but on customer table, it can only be one. I hope you understand. Please, have I answered your question, Raymond?
To some extent, I think my question has been answered. But when you ask a question about what customer 23 purchased, and we made reference to the dimensional table where we have the primary keys. I think under the product ID, product ID 3, what we have there is banana, and you said what we have on the product ID under this other side where we have the foreign keys, that if we should check it on the primary where we have the primary keys, is the same thing. So my question is that, does it mean that this other person, the customer 13, the customer with the ID 13, purchased the same thing with 23? Because under the product ID here too, the person is having product ID 3.
Okay. Yeah, thank you. Yes, they purchase the same thing. So do you understand now?
Yeah, my question is answered now. Yeah.
Thank you very much. So hope we are all on the same page. Any other question before we proceed? Any other question?
I have a question.
Okay.
I'm still trying to understand the concept of normalization and denormalization. So normalization would allow you to remove redundancy from the data, right? By dividing your data into subgroups and then making reference from one table to another table within that arrangement that you have. So is denormalization a direct opposite of that action, of that process?
Yes, sir. Yes, direct opposite. When you denormalize, you reduce dimension. You join them together. That's it. So
why are there any instances where denormalization might be useful?
Well, I don't know, but there are some instances that they just want it to be in one table. So in that case, you just use your join statement to join the tables together, and you you move it. I mean, you select into another table. You create another table with different dimensions. You join them together. You create another table. Maybe you join two tables together to create one. What you are doing is denormalization.
Okay.
Okay,
Again,
thank you.
Again, Mr. Alaka, my own other idea about denormalization is that a situation where you can get the same set of information in one place instead of, because during normalization, I believe that same set of information will be highly scrutinized on how it can be in the same place because of the rule set that has been in place. But during denormalization, a lot of the same set of information can be in the same place to allow this information to be called upon easily when you are requesting for it. I don't know if that makes sense.
Yes. Yeah, you're right.
Can I contribute to that?
Yes, please.
Yeah, I think in my personal opinion, denormalization can be used in when you have other type of regional management, relational database management system. Yeah. So let's take, for example, when you're talking about MySQL. MySQL is a non-structured relational management system that can take in any kind of data. Like MongoDB. Yeah. So in that case, we can use a denormalized data in that. But when you're talking about SQL, which is a structured query languages, if you try to use a denormalized data in a well-structured table that have a setup constraint, you're going to have a constraint conflict. So it's not going to work. You won't be able to put in those data into those tables in the first instance instead of using it. That is my feeling. That's my opinion. But Mr. Alaka has different. That's the right language, sir. I think.
Thank you very much. You're always the boss. Well done, sir. So another thing is that for easy read performance, you denormalize. You also do that. So user experience. So now another thing I want to mention before I leave here is now looking at this dimension table. Sometimes dimension table can also be large, that you might have a reason to also divide it, that you have dimension connecting to a dimension. For instance, let's use this example. Now, in this product ID, I have product name. I could have product location, maybe in a store. There's a particular place they divide, and they separate those products. This particular product will be at this location. Now, we have product category, we have product subcategory, we have product subcategory. In that case, I say, oh, I don't want this to be long. I want to have, now in this case, look at this now. We see how redundancy in this product, because this, what do we mean by redundancy? It means information being repeated. In this case, category, we have herbs, we have fruit and vegetable, sweet and snacks. They are repeated. I might say, no, I still want to divide it. I want to take out category and subcategory. In that case, I'm going to have a category ID, and which will be the primary key on the category table. And on this product table, it means I'm going to have category ID as a foreign key. So in that case, what I'm going to have, I'm going to have an extension whereby two tables are connected together before they connect to a fact table. That is the foundation of the snowflake schema. Let's proceed. So now look at this database entity relationship diagram. This is what I showed the other time. So as a start in a star schema, this is what you're going to see. You see the one at the middle will be the fact table, while the other one will be the dimension table. So snowflake schema, this is what I just explained. Snowflake schema. So now you see we have a category ID, we have some category here, and here now we've been able to reduce this. Now product 3 as category 2. If I come to 2 here, I'm going to see fruit and vegetable. This is what we call a snowflake schema. So don't Don't be panicked when you hear those big names. Yeah, easily. And why is it Snowflake? Can you see this? More normalized. More normalized. So normalization is the act of reducing redundancy. I hope you understand. So this is Snowflake.
Do you mind explaining that Snowflake schema again, please?
Okay, Snowflake schema is normalizing already normalized table. If you remember, here we have this. This is normalized, but can still be further normalized, whereby we still have redundancy. We still have this category appearing twice. If you have more of this product, it is sure that we are going to have this category being repeated more. So instead of that, we want to remove this category column and create another table for it and relate it to this category product dimension. So which is what we have here. Which is what we have here. So we further normalize it. Remember when I said star schema? Star schema is when one dimension is connected to a fact table. Individual, singular dimension is connected to a fact table. Once you are seeing a dimension connecting to another dimension, it has turned to a Snowflake schema. Do you get that?
Yeah.
Thank
you.
All right, so this is a diagram of a Snowflake schema. Now look at this. You can see all of them. Where is the fact table? I think this is the fact. Says is the fact. In this 6, we have this. So it's actually it's normal to have a Snowflake schema if you want to normalize your request further. So we understand that. So step to create a fact table. So if you want to create a fact table, what do? There are some things you need to consider. What are the questions you need to ask yourself? What are the key decisions we need to take during the design? What are the key decisions we need to take? What are considering the business need? The first thing is that what is the business request? What is the type of request that they want, type of report that they want to see? That will determine your design. Step to create a fact table. The first thing, identify business process for analysis. The first thing, says, order processing. What are the measurements that you want to use? What are the measurements, business measurements? That's the first thing. Then the next thing is the grain. I think I explained the grain the other time. How do you want to drill down your reports? The transaction, order line. You know, we have order. In one order, you can have many order lines. And in one order, you will have the amount, which will be total amount of all the lines. So if your own business request is, you just want to know the summary, you want to know the amount per user. For instance, the Jumia example that I use, that you Jumia, and like if I want to buy something from Jumia, I can say, oh, I want to buy many things. In one request, in one purchase, I can buy 10 items. So if your own report now, your grain will not determine how you want to drill it down. Do I want to drill it down to be able to know the amount per each of the item, or what I need is just to know the amount per order? That is grain. So that's the first thing you need to consider. And the next one is identify dimensions that are relevant. How do you identify dimension? You ask yourself, what am I looking for? What do I want to use to? When, where, how, why? Those are the questions you ask yourself. Time, location, product, customer. So those are the questions you need to ask yourself, because you need to have the logical design before you can go ahead and say you want to be doing your extraction and loading. You need to have the logical design, have your table design already, have your table layout, know the number of columns that you want, create it on data warehouse before you start moving. That will determine, answering the Mr. Dyer question, that will determine the type of transformation you are going to do. Your final, what you are expecting will determine the transformation you are going to do. So then the next, identify facts for measurement, divine by the grains and not by specific use case. By the grain. Don't say because they are asking for the summary amount now, and you design your data warehouse to only address that. No, do not design by specific use case. Design by grain. Okay, so we have this. We've explained this. So this is an example. We have this. Then for dimension table, you can see this. So now adding dimension table in this case, now they say, oh, we want to add time, location, and product. So if you want to do that, it means we are going to have your product ID, location ID, and date, which will serve as a foreign key.
People are calling, some of the Republicans on the Intelligence Committee are calling for an investigation. I mean, it makes some sense inside the Intelligence Committee for them to review this. But you know, the story.
Are you investigating us?
Minute, and I really think this is what's disturbed me, Wolf. People have allowed their personal views of Donald Trump inform their views about this. And I don't think that's the way we should head. We need to look at this. We need to be careful about this.
Can you mute him?
We need to get to the bottom of why it happened. But most important, if those documents were there and represented a threat to national security, of course you have to go and pick up those documents. Why now and not before? We still don't know the answer to that.
Well, let me get Charlie Dent's reaction. What do you think?
Okay. Can proceed. Okay, so we are here. So we understand this. So product ID and location ID says amount and other quantity.
Sorry, guys, it was a mistake. Sorry.
No problem. You are the senior consultant. Okay, so factless table. So I think I've spoken about this. Factless table. What is fact? Fact is the measurement. And if a measurement is not found in a fact table, it is called a factless table. In this case, sometimes only dimensional aspects of an event are recorded. Example, new employee is registered. So look at this. This is a factless table, no metric. So what we just have is this. So it is possible that you have something like this. It's possible. Okay. So then I explained this natural and surrogate key. So this is what we call natural key. Look at this key now. This is product ID. Look at the way it is. This is alphanumeric. So before you work on something like this, so you know, from different platform, different, you know, the aim of data warehouse, they are collecting data from different databases, whether NoSQL database, SQL database, PostgreSQL, SQL Server, Oracle, they have different structure. So the first thing you do to normalize it, to make it uniform, is that your key, you have to use a surrogate key. Once you use a surrogate key, then that has been resolved. And I've explained the reason why for fast data retrieval and to avoid modification. So we have that. So look at this. Natural key comes out of the source system. This natural key from the source system, it's come like that. And this is a surrogate key. Surrogate key is an artificial key. It's integer number, and the standard is that when you are writing it, you have this. Underscore PK means primary key, and FK means foreign key. Then surrogate key is created by a database, ETL tools. So when you are doing that, you create it. You create that. Then surrogate key benefit, it's improved performance, less storage, better join, undo, domain, value, nulls, missing file. I've explained this. Integrate multiple source system. I've explained this. Easier administration and update. Sometimes there are even no natural keys available. So when you have an heap table, so you do that. Then date dimension. This is very, very important. In your data warehouse, you must have a date dimension if you want to get report using date as a parameter, using date as a category, categorizing report as date. So this date dimension, you know, one of the most common and most important dimension contain date-related features you have from there. Using the date dimension, you'll be able to filter your report per day, per quarter, per week, per year. You'll be able to drill down. You remember, let me see shorts again. You remember that we're able to drill down this report. We're able to drill it down per, let me go up. You can see per day from the beginning. Now, this is per year. This is per month. Per month, I think you see I have a little this thing there. See, per day. So with this report now, with this, I can say, oh, I have a spike on this day. Why? Once you click on it, it will change orders. Then you see what happened that day, what is going on. And this is profit. This is profit by year, quarter, month, and day. This on this particular day, what happened? Look at the profit that day. Look at the Quantity, let's check this day. What do we have? You see how low it is. So do you see how important is the report? So as I click on this, as a as a manager, you don't want to see tables. You don't want to, as CEO, they don't want to see a list of reports. They want to see something graphically like this. They want to be able to click and it's going to give them reports. Okay, so we'll proceed. So we update. Kind of transformation. Good. Transformation. When you extract, you transform. What are the type of transformation that you do? Basic transformation, you remove duplicates. When you are taking your data to the data warehouse, you don't want to have duplicates. You remove duplicates. Then filtering rows and columns, cleaning and mapping, value standardization, key generation, joining, splitting, aggregating, derive new values. These are the things. We are going to go through all this in the practical, but I'm not sure we can do the practical today for us to understand it very well. We are going to postpone the practical maybe next Friday. But before then, I want us to go through the slide. Go through the video, understand it. So that when we are doing the practical, it will be so easy. I have all prepared. I have everything here. The pipeline I can show us here. This is the pipeline. I won't want to bug us with that today. This is the pipeline that you use to move the data. This is what I use to move those. You can see split field. This one is after getting the data, split the field, replace string operation. All these are transformation that are done before moving to data warehouse. All these are the pipeline. These are pipelines. These are pipelines.
Is this Power BI or
this is an ETL tools.
What
is
an
name? ETL tools, Pentahall.
Okay,
this is an ETL tools. Now, I mentioned that we're going to use two ETL tools, Pentahall and SSIS. We are not going to do that today for us to understand it better. But everything, once you have to go through the video, understand it, so that next class you will be able to contribute. Because I want us to understand it, not just to to show you the slide and you forget it. After I will actually even give you the material, give you the installation that you need, the file that you need, so that you will be able to follow through the practical in the next class. So we have it here. So let's proceed with the class. We're almost done. So after this, you ask question and we remunerate together. So these are the type of transformation that can be done from staging environment to the data warehouse. So now this is the plan to go to, for the process. The first thing is look at the problem and plan. The next thing, set up tables and schema. The next thing is output, staging tables. The next thing is transform and load, read from staging, transformation, clean and extract, update and insert. This is what we are going to follow in the next class on the practical completely. So I want us to ask question now. Question time. So please, we drop the number. Okay. Please, question, please. Please already send my number. Please send your number, or we want to collect the numbers so that we can also follow up with you and some subsequent class and other program that we want to do. So please, question time. Please, let's, we have a lot of people here. We have Oluwatosin, Fabuyinde, we have my people. So please, time to talk. You can turn on your video. Let's see your beautiful faces. It's an interactive class. So, okay. Question time. Feel free to ask any question. We'll be able to answer it.
So, thank you for the presentation. My question is, the sources of data, they could be anything, right? Be it in written form, even in voice as well, right? Or they have to be written in text only.
The data bar?
Yeah, all the different sources of data that you are extracting. Can they come from audios as well?
Yeah, sure.
Is there a process? Okay.
That's yeah. You know, I said the other time that data is the new oil now. from voice, you know, we have some tools that translates voice to writings. And one of the things that we do in transformation is to be able to transform it and to be able to clean it and put it in a table form. You know, one of the things, we have no SQL databases, Crunchbase, a lot of them like that. The function is for you to be able to extract them and transform it in a readable form. So from voice, also a data type. Let me show some things. Data type, the different data type that we have. So the two tools that we are going to use. Okay, yeah. No. This is okay. Yeah. Okay. No. Yeah. Yeah. We are creating. Let me just show us one. Let's zoom. Okay. Let me create a data connection. Database connection. This is the database connection that connect to all the. Okay, this database connection. You can see all the databases we have here. These are the connection type. Azure is there, anywhere that is coming from. The one that I have not, Google, BigQuery, Hadoop, Hive, all these are cloud technology, IBM. You see a lot of them. You see a lot. It's a lot. So all these are the different types of data source where you can get your data and use the transformation for it. So further question, please. Question.
Thank you very much. Just one question I just want to ask. What are the main sources that you have to look into when suggesting warehouse?
Okay. Yeah. Thank you for that question. You know, when you want to build a data warehouse, you have to look at your available resources. What do you want to put in the warehouse? Where do you want to get those information? We can get from flat file, from CSV file. You can get from your SQL server, from different, it depends on what your company is using. So it depends on your data source. So that is whichever data source is coming from, there's availability from there. I can open my this into my Visual Studio. I use Visual Studio for the SSIS. The same thing you have there. The same thing you have there. So it depends on your okay, this integration. I'm not sharing my screen. Let me come back. Where's this thing again? Where is this thing again? Okay. So it depends on what you want to do, what you want to achieve. This is Visual Studio that we use to build SSIS package. SSIS package. This is it. Come here. So, but I don't want to go into it today. I don't want to go into it today. See, I have a lot of tools for it. So, question, please. Question. Other question. Please, have I answered your question? Hope I was able to answer your question.
Yes,
okay.
But you didn't expatiate it very much. Well, it's okay.
Okay, so you know what you ask is that you know what to consider. This is what you have that you consider. You get, so anything that whatever data source that you have, you can bring it in data warehouse because we have those connection type available. So that's it.
Okay.
Question. Stop sharing. Okay. Question. We have a lot of senior DBAs here. Well, please ask question. So I'm very happy that we understand the topic.
So Mr. Alaka.
Yep.
Let's say you get a question that is asking you, what do you think is the role of a database administrator in terms of warehousing? How can you answer that question?
Okay. Is data itself, okay, I will just answer it. Number one, it depends on the environment. There's some environment that they employ you as a database administrator and you are in charge of, you know, you know there is a difference between database administrator and database developer. but there's some role that they employ you for, that you are the one working as a database administrator, you are working as a database developer, you are working as the ETL engineer, you are working as a data engineer. So that question, to answer it, you have to, I mean, you have to answer it as regards the situation, the terms. I mean, you have to understand what they need in that environment. Normally,
okay, let me put it this way.
Okay.
Let me put it this way. Your company has a warehouse developer. They have the reporting team. They have you as a database administrator. They have integration team as well. What would be your role in collaborating with these teams when it comes to making use of the data warehouse?
Okay, I think I understand you now. You know, everybody work together as a team, because without you, they will not have access to the data. And now, number one, okay, your role, you have to understand the process, know what they are doing to your data. That is not what is going to corrupt you. Because if anything happens to your data, you are going to be held responsible. So by understanding the process, that there is a staging environment. All those environments, you create it for them. There's a staging environment. They're on different databases, staging environment and their data warehouse. So your own is you give them the permission, and you also monitor that, they are doing the right thing. So there is no, I'm not sure there is anything, technical this thing you want to do. If all those roles are specified, if they are specified, but you work together, they carry you along when they are doing all those all the processes, they carry you along. Another thing is that you also automate the package. When they want to automate the SSIS package, you are the one that's going to do that. All they need to do is to publish the package to your SSIS environment, SSIS, which is on your SQL server. So you go there, you pick it up, and you use your SQL server agent to automate the job. They are the one that's going to. So that's why I said everybody work hands in hand. So your work, you see, you need to do the automation for them.
So can I add to that?
Yeah.
Okay, Mr. John, honestly, without a production environment, there would not be any data warehouse, right? You might, I might be wrong. I'm starting to be corrected if I'm wrong. Your data warehouse, data is going to come through somewhere into your data warehouse, and that data is going to pass through pipeline. And Mr. Alaka was trying to talk about pipeline. My general overview, my high-level overview of a pipeline is that the data from the different sources, which in this case is going to be a data producer. We have the data producer and we have the data consumer. The data producer in this case is going to be your production environment, and you as a DBA, your core responsibility is to ensure that you protect that production environment. You ensure that you grant access to people, minimum access that they need into that place. That is, you have to monitor any kind of access into your production environment, which in this case is going to be your data producer. Then when the data actually gets into the data warehouse, basically most of the things that is going to be happening in the data warehouse, most of the functions are going to be performed by the developers, because they are going to be writing script to generate report. They are going to be doing all sorts of things in the data warehouse. But at the same time, it might still be your responsibility to monitor permissions in this scenario. Although your data is coming from the production into the data warehouse, it's going to pass through some process, which is the data pipeline that we're going to see next week. But you still have the responsibility to ensure that you monitor any form of anything that can cause performance degradation in the production environment and the data warehouse environment. If your data warehouse environment is an environment whereby developer is doing a lot of query, a lot of DML, DDL operation, it is your responsibility to make sure that you monitor your indexing, you monitor any form of fragmentation, anything that can cause performance degradation, anything that will make retrieval of data difficult. It is your responsibility as a database administrator to ensure that you put that in place. Stand me if I'm correct.
Yeah, thank you very much, Mr. Dayo. Thank you.
Okay, so just a follow-up to that. So Alaka was explaining the stages. So you have this stage where you extract data from multiple sources and you bring them to the staging environment, right? And that's where the transformation is done before loading into the warehouse.
Yes, sir.
So where does the DBA stand in these three stages? Is it in the transformation? Is it in the extraction or in the loading?
The staging we're talking about, the product, when you're talking about data integration and we're talking about data from different sources, like I said, we have the data producer, we have the pipeline, and we have the data consumers. The data consumers are most of the reporting applications that we're seeing on the screen, like your Power BI. Those are the data consumer. They are the one that are actually consuming the clean data that come from the production, which is the data producer. The data consumer, which is all these Power BI, SSRS, are sitting on the data warehouse. Like I said, when we're talking about the staging, we're talking about the production, we are still talking about, I don't know the kind of relational
Okay, wait. So is it safe to say we are more into the staging environment as DBAs from your explanation? That's where most of our duties and responsibilities will be more relevant in the staging environment. Is that what you're saying?
Let me put it this way. Maybe you're going to understand. We have different kind of environment as a database administrator. You have to monitor different type of environment. We have the production environment, we have the staging environment, we have the development environment, and we have the test environment, and we have our data warehouse. So in this environment, it is the responsibility of the database administrator to ensure that you monitor permission, you take care of any kind of issue that can cause performance. You have to make sure that you ensure that all your SQL Server agent jobs are running. You have to ensure that, most especially in the production environment, you have to ensure that the backup are taken and some other stuff like that. So when you're talking about this staging environment, it's still the responsibility. Staging environment is a SQL Server environment. Like I said, it depending on the relational management, database management system that you're actually using. So if it is SQL, when we're talking about production environment, it is SQL. It is SQL Server environment. It's a SQL Server instance installed. But in this case, it's the one that is actually generating the data in real time. But the staging environment will be a place whereby we can have multiple production environment in a business, in an organization. We can have multiple production environment. And when you need to extract data from this multiple environment and transform them, you need to put all of them into a place, which is the staging that Mr. Alaka is referring to, whereby you're going to do a kind of transformation on them before you eventually load them to the data warehouse. So at each production environment, you have to ensure that you have, you have to ensure that the DBA is actually doing their job to ensure that they secure the environment the way they are supposed to secure it. It could be the production environment, it could be the staging environment, it could be the data warehouse environment. So it's still the job of the database DBA to ensure that you secure those environments, you grant permission following the principle of less privilege, you ensure that anything that can cause performance degradation. Don't forget, the data we're going to be keeping at the data warehouse, we're going to be writing report. Most of the things that Mr. Alaka is showing us is using scripts at the background. Is using select script. He's selecting something from different tables, using the relationship from those tables to actually give us a graphical interface report that we can actually relate with. So it depends on, for this to function very well, you have to ensure that the indexes are not fragmented. You have to ensure different kind of things are put in place to ensure that you can actually retrieve data from those database, from the data warehouse. So those are the things that you have to tell them, to let them understand that you understand your job as a database administrator in each of these environments.
So, Mr. Dayo, my follow-up question to what you just explained, I understand what you are explaining now. is, for example, you spoke about multiple environments.
Yes.
Okay, you are a senior DBA right now. You
No, I'm not a
work.
senior DBA. I'm not a DBA.
You are already senior. Okay, let's put it, you are a DBA because you work, you are in an environment and you know how it works. So my question is, for example, in that multi-environment where let's put, for example, yourself, and let's say yourself, you work with MS SQL, right?
Okay.
Alaka work with Oracle.
Okay.
And Mr. John work with MySQL. So if you are going to get information from these multiple environments, do you need their permissions to do so, or you just the information just comes? How does this thing works? What is, or how does it, as in, what is the formation? How does it come in place? It's also, this question is also for Alaka.
Okay. Maybe Alaka is the chairman here. I can.
Well, you can start it.
Okay.
Yes.
So my understanding, which is the same knowledge Alaka passed to us that we actually developed on. My understanding, like Riley said, let's take, for example, the three people you mentioned work in the same company, right?
Yes.
Whereby, let's take, for example, Mr. John work in sales, and sales is actually using Oracle.
Yes.
I work in production. I work in operation department. We are using SQL Server, and you, Mr. Pua, you work in the HR, and you're actually using MongoDB. And now, don't forget, for a top management level, for a director, for an executive director, to be able to make what is known as a strategical planning, which is a long-term planning now, you need to have a general overview of the entire data that is going on in that company. And don't forget, these data are generated from different relational management database system. You know, we have data from Oracle, we have data from MongoDB, we have data from SQL Server. Now, for us to be able to generate a report or a dashboard or a dashboard like what Mr. Alaka showed us now, the management needs to put all this data together into one place. And that is why the concept of data warehousing very, very important. That is why it's becoming common now. Because most companies now, they are going into they want the data to drive their business. So they don't joke with the data. So they want to make sure that they put all those data together. Even data that is coming in an Excel, in a flat file, they still don't want to joke with it. So they are trying to put all those data together. So now come to your questions. If you are the Oracle DBA, if I am the SQL Server DBA, Mr. John is the Mongo DBA, then we are working for the company. We all understand that for the executive ED operation to make a strategic planning for this company, you need to see the data. So we all know that at any particular point in time, when they need the data, we have to make those data available. And that is why a developer, a developer that is developing the data warehouse will have developed the data warehouse, put necessary constraints in place, and it will now develop an ETL package depending on if they are using, depending on what technology they are using. But whatever technology they are using, all of them will still use a ETL package. So they must have developed that ETL package for each of us to deploy it. So when we deployed it in our SQL Server, we're going to automate it. And each time those packages run in our production environment, it will automatically take those data from different sources and put them in the data warehouse.
Wow. I understand. So meaning this thing automatically happens with the ETL packages taking those informations to the data warehouse.
Yeah, if you automate it, don't forget that the data that is coming from the production environment is coming in real time. So the data you have today is going to be different from data you have tomorrow. So most company, most businesses run their ETL package at the end of business day, every day.
They schedule them. They schedule them.
Yeah, they schedule it to run every day. So probably they schedule it, maybe you close at 4. If they want to, like a bank, if you want to get the data, that day data, you have to schedule an ETL package that will take the data of today and move it to data warehouse. Don't forget that the data that is going to be generating at the production environment tomorrow is going to be different. So they are going to run an ETL to, transform those data.
What's the common ETL package that companies use?
The one I've seen is SSIS.
SSIS is common. SSIS is common.
SSIS is the common one that I've seen.
Okay.
And in some, I just want to chip in something. In some organization, all of this team work together. You as a DBA, with the SSIS guys, some company, they have SSIS people. And as it is now, they even want us DBA to be heavy on this SSIS. So as a DBA, is a must that we know this SSIS, this ETL process, because in my environment now, on my 3rd day, they just want me to jump on SSIS. I have to tell them, take it easy, okay? I'm just, you understand what I mean? So it is very important for us to really get our hands dirty on this thing, because all the teams work together daily in my environment to make sure that this package go out every day at the end of business day. They must be generated. So everybody have their own quota to contribute to that. Like what Adayo said.
Wow. Okay. So, Mr. Alaka, over to you, sir.
Thank you very much. Thank you all for the contribution. So I've said it well, and I'm glad I know we're able to get something out of the lecture today. So please, I'm encouraging us, please, before the next class, which will be next week, Friday, by God's grace, you should get the video, then the material that will be needed. So in this class, we are going to look at 2 ETL tools, which is Pentaho and SSIS. So Pentaho, the difference is that PostgreSQL, most cloud technology companies, they use PostgreSQL compared to SQL Server, and the reason why is that PostgreSQL accommodates a lot of data type that are not accommodated in SQL. In fact, PostgreSQL can work with NoSQL and SQL, unstructured database and structure. So and in a fast-moving application like a trading application, if anybody come to your site and they observe that your site is slow or something is, and try to do something and it's not allowing them to do, they go to the next one. And the advantage of PostgreSQL to SQL is that, in SQL Server, we have commit, what do we call it? That such that one blockage, when someone is trying to access a resource and someone is trying to access the same resource, there'll be a blockage. So in PostgreSQL, that is not so. 2 people can access the same resource at the same time. They have the way they manage it. So we are going to look into PostgreSQL using the ETL process there, which is the Pentaho, and we're going to look at the SQL Server, which is the SSIS, SQL Server integration service. So the file that we need, please, if you are here to put your number, because there are some of us that are not in this community, so we want to have a dedicated WhatsApp group for this class. Subsequently, we have other things that we want to do that will be intimating us through that group. So the material will be sent through the group. So make sure that you put your number there. So thank you all for the contribution. I really, we have more than 20 people today. So thank you very, very much. So I leave it to